Let's learn trick to find hybridization. Tricks to find hybridization. Few rules. Case 1. Find total number of electrons in a given compound. Second case, if number of electrons are greater than 8, divide by 8. Third rule, if number of electrons are less than or equal to 8, divide by 2. Let's take a compound. Example, suppose we have CH4. Now number of electron in outermost shell in carbon is 4 and that of hydrogen it is 1, so it is 1 into 4, that will be 4 plus 4 and it will be 8. Now it is 8, so rule number 3 will be applied. So we'll be dividing 8 by 2. 8 by 2. So it will be 2 4s are 8. In this way we'll get 4 true bonds. So there are 4 bonds which describes hybridization as sp3. How? Let's see. Let's see the number of orbitals in a given blocks. Suppose S has a single block which is S orbital. For P it has 3 orbitals. So it will be P, P and P. For D it will have 5 orbitals. So it will be D, D, D and D. Now since two bonds are 4, so therefore we can count up to 4 places. It will be 1, 2, 3, 4. So it will be sp3. If we take these 4 orbitals, so it will be sp3 hybridized and shape of it will be tetrahedral. Now here there is no lone pair. We can find number of lone pairs if there it is. Since in a compound the central atom is attached to 4 hydrogen and true bonds are 4. Both are equal, so it will be 4 minus 4 0. There is no lone pair. Let's take another example. We can take NH3. Now number of electrons in nitrogen is 5 and for that hydrogen it will be 1, so it will be 3 into 1. So total it will be 5 plus 3 which is 8. Now it's less than 8 or equal to 8, so divide by 2. So it will be 2 4s are 8. Now there are 4 bonds Now there are 4 bonds and number of atom attached to nitrogen is 3. So it will be number of lone pair will be number of bonds when divided by 2 minus number of hydrogen attached to nitrogen. So it will be 4 minus 3, which is 1. There is one lone pair. Now hybridization for it will be sp3 only, because there are 4 bonds, so it will be sp3 hybridized only. Now let's see the structure. Now for this structure will be, if you see the structure, it will be tetrahedral only, so it will be NHH and there will be one lone pair, so it will be a pyramidal shape. Pyramidal shape in tetrahedral, because hybridization is sp3, so it will be tetrahedral and there is lone pair, so the structure will be termed as pyramidal shape. We can take another example of it. Suppose if we take BeCl2, calculate total number of electrons, so it will be 2, and in chlorine there will be 7, so total there will be 16. Now the electrons are more than 8, so it will be divided by 8. We get 2, so it will be sp hybridized. So the given structure will be like this only, and this is linear in shape. Now there are 2 bonds and there are 2 atoms attached to it, so total number of lone pairs will be 0. It is lone pair will be 0. Let's take another compound. Let's take HCF2. Now in xenon there are 8 electrons. For fluorine there will be 7, so it will be 8 plus 14, there is 22 electrons. Divide 22 by 8, it will be 8 2 just 16, so 6 divide less than 8, it will be 2 3 just 6, so total bond is 5. So geometry will be like this. Here it is xenon. Now to xenon there is 2 fluorine attached to it, but total number of bonds are 5. So lone pair will be 5 minus 2, that will be 3 lone pair. Now 3 lone pair will be here. And 2 bond pair will be here. So generally the structure is linear. For what? It is trigonal bipyramidal. It will be trigonal bipyramidal. And the hybridization is total number of bonds are 5. So hybridization will be, it will be sp3 314, and that will be D. So hybridization is sp3D. We can take another compound. It is HCF4. Find total number of electrons. So it will be 8 plus 4 into 7. That will be 8 into 28. 8 plus 28. So there will be 36. More than 8 divide by 8. It will be 8 4s are 32. 4 divide 4 by 2. So there will be 6 bonds. Now atoms are attached is 4. So lone pair will be 6 minus 4. That will be 2 lone pair will be there. According to this, since 6 bonds are there, so structure will be like a square. It will be like this, that is octahedral shape type. Here it will be Xc. Now what is the hybridization? Since 6 bond pairs are there, so it will be sp3 4 and it will be d2. Hybridization is sp3d2. Now for the shape it is xc. There are 2 lone pairs, so lone pair will be attached over here and all the f will be attached at this square position. So it will be attached like it will be a square planar in octahedral. Let's take another compound. Take S2O. It will be 2 into 1 plus 6, so we'll get 8 electrons. Divide 8 by 2, you will get 4. So according to this, hybridization will be sp3, that is tetrahedral. Now the shape will be, there are 4 bonds but 2 central atoms are there, so lone pair will be 4 minus 2, which will be 2 only. So our structure will be like this one. Here there will be O, there is 2 lone pairs, so it will be like this, and there is H, so lone pair are like this, and hydrogen will be attached like this. This will be bend shape. This will be bend shape, or we can say V shape in tetrahedral. Thank you. We can find hybridization in such a way. Thank you so much.